welcome to the Astro. In this Python tutorial on Astropy for professional astronomy, we are going to create a multi-extension feeds image or data file. Okay, so here feeds implies that it's a flexible image transport system, and it is used to store data and table from astronomical observation. So we are going to create a multi-extension feeds table. So what is meaning of this multi-extension? You can see from here. You can see we have like multiple layers of data, right? Data like we have 4 layers of data, and we have like primary HDU. After that, we have like 3 extension. So you can put here image or data cube, or you can also put your binary table in this extension. So we have to create a similar multi-extension feeds file, okay, which contains image, a cube, and data. So let's do it, okay. Right. Well, so before starting, you can also watch my tutorial on like how to create only feeds image file, and also how to create only feeds data file. Okay. So if you are beginner, then you can also watch the tutorials, and like then you can jump to this tutorial. It will be helpful for you. Anyway, I will start these things from the beginning. Okay. All right. So for that, I will import some libraries, right? So import libraries which are necessary for our working in this tutorial, right? So I will import numpy as np. So this will is for like your numerical Python and array. So this will like used to create data and array, right? Then I will import Astropy. So from Astropy dot input output import feeds. Okay. So this deals with your feeds file, right? Opening, closing, and reading and writing. So these two libraries are very necessary. Now move to the next step. Okay. Now I will create your data. Okay. So now I will create data for multiple HDU extension, right? So first I will create a primary HDU. Okay, so I can create my primary HDU. So I can create my primary HDU, right? So I can so this is my variable name. You can make it anything as per your wish, and then I will type here feeds dot primary HDU, right? So and put some data into that, right? So see what it takes. So it will take your data and header. Okay, so header will be seeing it later. So we're not going to put header right now. So I will put my data. Okay, so data equal to, I can give it, say I want to give some np dot I want to give say only once, right? So it contains only one, and it is say it is 5 cross 5. Okay, so it's like it's a matrix containing 5 cross 5 size. Okay, so this we have done. You can also check it what it contains. Now this much we have done. Now create a image HDU. Okay, so uh, create next extension. Okay, so I will create here image HDU. So image HDU, right? And then you can start as a feeds dot image. So it will put image data into that. So image is a 2D data, right? And then you can put data equal to np dot. Okay, and you can put some. I mean, you can put any number you want. So I will put here np dot once similar to the above. You can put any data if you want. Okay, so okay, suppose that I want to put this data. So for that, let's get a data. So just call image data, right? And you can create say np dot linear space, right? 1 to 100 and say so 1 to 1000 and 1000 data points, right? And then you can make this data as a 2D. Okay, so for that just type here np dot reshape, right? Reshape, and this is your data, and make it row into column. Okay, so you can make it say 20 rows and 50 columns. Okay, so this is your data. Now you can put your data equal to image data, right? And you can also give your name. So you can see, you can also give the name. Okay, so if you come here, you can give the header name. So I just give the, I will skip the header and give the name. Okay, so name I can give name equal to, I can give uh, my, or just give image. Okay, just here type 2D 2D image, right? Now this much we have done. You can see your image data if you want here. This is the data, it's 2D array, right? Now we have done this much. Okay, we have created a primary. Maybe I can write in a different cell, right? Split it. Now we have created a next. I mean, this is the primary, but maybe create a data of multiple. So I will. So this is for primary HDU, right? And this is for the next extension. So extension 1 you can call it, and then I will create extension 2. Okay, so now create uh, extension 2. Okay, so this will like continue of your data cube, right? So I will give your data cube, and this is your image data. Now so data cube basically it has a 3 axis. Okay, so I will put my data cube here. So data cube you can give okay, so I will create like input dot linear space. I will create only number, so 1 to 1000 to 1000, right? And then I will reshape in the 3D array. So np dot reshape, so it will reshape the data into 3D array. So I will give here uh, 10 rows, 10 column and 10 chance. Okay, so this will like a 3D data. image HDU2, or just call it cube HDU equal to feeds dot, it also image, so image HDU, and you can put your data, so data equal to data cube, and give name equal to you can give say 3D 3D data. Okay, now 3D image or spectra, I think that will be fine. Okay, so 3D image data, put it that image data. Now we have done the extension 2. Now I will now this much we have done. Now I will create one more. Okay, so now create here create extension HDU third, and it contains binary data. Okay, so binary table contains binary table data, right? So for that I will define some columns. Okay, so column 1 just called C1, and you may recall as fits dot column fits dot column. Okay, and then you can give say name, so name you can give you can give a, right? And then you can put some data, so you can give your array. Let's see what it takes. So it will take your take the name, right, and then format and the data. Okay, so I can give my array equal to np dot linear space, right, and I can give from 1 to 10 some 10 data points, right, and I can give a format, so format I can give say key format, so this is like 64-bit integer, right? The k means like 64-bit integer, right? So such we are done. Now create a second column, c2 equal to again fits dot column, and just I will copy this stuff and I will change something into that. So just call it column B. You can add more. Here I can give and format k, right? You can add more, one more you can add if you wish. So I'll just copy paste here, and you can make it C, and you can go from this time you can go from -10 to -100. So like we have 3 columns. Okay, we have to put in a binary table. Okay, so for that call a function feeds dot bin table HDU. Okay, so bin is binary table data unit, and dot from columns you can give the column names, right? So you have column names C1, C2 and C3, right? So this way you can put your table in the extension third HDU. Okay. Now we have defined this data. Now put in a fits table. Okay. Combinedly. So for that, what I will do, I will uh, I will uh, I will define a variable called uh, call full, or maybe you can call header data unit SDU. Okay, so SDU equal to fits dot, or you can just call it like full fits file, or yeah, full file you can call it. So full file, full data, right? Just call it file. Just call it file equal to, you can call it your fits, right? Fits dot, and like add your all header data into a list. Okay, HDU. So HDU list. So do like give a list of all your headers, and you can put all your you can put all your right your headers. Like we have primary HDU, image HDU, cube HDU, and table HDU. Okay, so I will put here primary HDU, then image HDU, then image HDU, comma, then you have cube HDU, cube HDU, right? After that, you can give the table HDU. So table HDU, right? Table underscore HDU. All right, okay. What is, we have 5. What is the mistake here? So we need to put here square bracket, right? Now it's fine. Okay, so here you can see that we have created this all header in a single HDU list in a fits file, right? Now you can just find the file what it says. So you can see there are so many things. So better like type here. So get file, get information about created fits file. So for that, type here file dot info. Okay, so here you can see that. Okay, you have like a primary HDU here. Primary HDU, you have like 5 is to 5 data. Dimension is 5 into 5 and plot 64 data. You have 2D image HDU, right? HDU, right? And we have 10 into 10, 10 into 10. Okay, it's a row, column, and channels. Okay, and last we have a bin table HDU. So it contains only columns data. So you can see you have like 10 rows and 3 column. Okay, so 10 is that. So like 1, 2, 3 columns, and like each columns contains 10 rows. So this way like you can create a multi extension fits file, right? Now next what I'm going to do, I'm to write some header information in every HDU. You can see that we have like a uh, like a HDU. Okay, so data. So there's some information about the observation of the data, that what these data represent. So I'm going to, so uh, I will be creating header information regarding each HDU. Okay, so what this contain? So let's see how to do. All right, so let's create for the header information for the primary HDU, this HDU. Okay, so for that I will initialize my header as a HDR equal to feeds dot header and function, right? So this is like your initialize your header to write into it, and then I can give my HDR and I will index it as a string. Okay, so I can give, say, I can give I can give any keyword. Say I can give array, right? So array of the object, or just simply type telescope. Okay, so tele SCOPE. But say here you can like put here maximum you can put 8 words. Okay, so 1 2 3 4 5 6 4, and so just remove one, and so maximum 8 you can give here, right? So telescope I can give, say, I can give JWST just for example, right? And I can give one more information. So HDR I can give, say, comment. So COMMENT. Okay, so I can give, and here you can write this is primary HDU, right? So two things are given. Now I want to write in the in this primary HDU, okay, file. I mean the header data. So for that I will I will I will recall my I will update my this primary HDU. Okay, so update my, so let's dot primary HDU and see what it takes. So just run it, and so basically this would be primary. There should be primary HDU, right? There should be not function. There should be primary HDU. It's a capital primary HDU, and so it will take your data and header. Okay, so data we can extract from here. So you can record here as a data equal to, you can give here data 1 and just copy this code and put it at, so run. What is mistake? That's fine, right? So run it, and so here you can put your data equal to data, what is this? It's a data 1, right? And then put your header equal to HDR, right? So this way you can get your header. Okay, you can and then again update your HDU list. Okay, so for that just go and copy this file, and again you can put it, say, file equal to primary HDU and run it. So here you can check it. If you print your file, so file.info, so and then if you type file 0 for your primary HDU, right, and dot header, so you get some information. So here you can see that it's a standard bit file, 64-bit data, and you have two axes, your rows 5, column 5, and you have like telescope is JWST, a commentary, this is primary HDU, right? So this way you can write similar stuff you can do with like just change your data to your like here you can got your image SDU and there you can write, okay? So here I can go one more step further and put I'll be creating header information for image SDU, right? So image SDU. So for that I will just copy paste this stuff and I can slide as header underscore image, right, and fits dot header. So telescope here I can see, here I can give say observer. So maybe you can add something to this, no problem. Here you can call it image, and here you can add one more SDR image equal to, you can call it as a observer equal to, you can give my name, I can give my name here, say equal to Jyoti Prakash, I can call it, right? So now do that same step, right? So you can make it your image SDU, right? So add here one column and image SDU equal to, just give your fits dot fits dot image SDU, right? Give your data. So data is your image data, right? So data is your image data, and header is your SDR image. SDR image. What is this SDR image not defined? Okay, now it's fine, okay? So here you can, if you and again update your file, okay? So I just copy this code and I will put here, update my whole HDU list, right? So you have this image HDU, so it will be updated, and if you got your file once, okay, so like one is your image HDU, so file one dot header, so you can see it's telescope JWST observer Jyoti Prakash, and this is image HDU, right? So there should be image. Now it's fine, right? Now final thing we are going to do, we are like save the data, okay? So save all HDU into a single feeds file, right? So for that, I will type command for saving feeds file. So you can write here. You can write. So you have put all files, all data in this file. So just type here file dot file dot uh, write to, okay, and give the function. So here you can give your file name and overwrite equal to false, so that you can update on its own. So I can give my, here you can write multi okay, multi extension dot multi extension file dot fetch format, okay, and I can give overwrite equal to true, so it will have an update, it will get updates on its own, right? So let's check it. Is there a file corresponding to this name? So here you can that you have a, so refresh it. So here you can see that uh, you have a file called multi extension underscore file dot fits, okay, so you can visualize this file and you can read. So you can read saved file, okay, saved file from, okay, so for that you can call it um, my file as a variable, and you can open it. Fits dot open, so this is command for opening your fits file. So fits dot open, and you can give, so run it. So if you give your my file dot info, so this will get information about the fits file. You can see the file name is multi extension file dot fits, and you have primary HDU 5 cross 5 dimension, image HDU 15 to 20, then image data cube you have 10 row, column and channel, then you have pin table HDU the 3 column and 10 rows, okay, and you can also extract data. So you can extract data from each HDU, right? So for first I will like called data 0, okay, so just type here my file 0 and dot data, so you got your data here, right? So there should be a small a, data 0, right? So you got here. Similarly you can get from the second HDU also. So just copy it, paste it. So data 1, so file 1 dot data, okay, so this way you can extract. You can also get the header information from this. So just type here my file 0 dot header, so you can also extract the header along with data. So I hope you got the idea that how to do this stuff using fits Astropy, okay. So let's recall the whole code once again. So our objective was to like create a multi extension fits image file. So we have like primary HDU and 3 extension HDU. So I have imported libraries. I have created the primary HDU of 2D data, then image HDU of 2D data, then extension. Second is your cube, and the last extension is your third HDU. It's called binary table HDU. I have then combined all HDU in a single HDU list. Okay, then I have uh, put some hidden information in primary HDU and your image HDU, and then I have updated the file, and then I have saved this file into a single bits file. Okay, then I have read a file, I've extracted the data and some header information. Thank you, and I hope this video is very useful for you and it will help in your further research. So thank you, and if you feel any problem during getting this data file, so let me know in the comment. Thank you.